if x is an integer, is 9 to the x plus 9 to the negative x equal to b? So in order to know whether this equation is satisfied or not, we'd need to know about values of both of the variable x and the variable b. So statement number 1 gives us this rather complicated expression, 3 to the x plus 3 to the negative x equals the square root of b plus 2. Well, this is kind of a monstrosity, but we do notice there's a radical on the right side, and it'd be nice to get rid of that. And also 3 squared equals 9, so that kind of tips us off that maybe what we need to do is simply square both sides of this equation. So if we square both sides of the equation, well, on the left side we have to be careful. We're squaring a binomial. And you may remember that when you square a binomial, you cannot simply just square the individual terms. That's one of the great mistakes of algebra. In fact, what you have to do when you square a binomial is squaring means that you're multiplying something by itself. So you're multiplying the binomial by itself. You have to distribute out, and you wind up with an expression that looks like this. A squared plus 2ab plus b squared. So what we wind up when we square this binomial, we wind up with 3x squared plus 2 times 3x times 3 to the negative x plus 3 to the negative x squared. And on the right side, we just undo the radicals. So square root of b plus 2 squared is simply b plus 2. Well, on the left side, we still have a little more simplifying to do. So I will point out here on the side that 3 to the x squared, the laws of exponents tell us that that is just 3 to the 2x. And in turn, we could write that as 3 to the 2 to the x, which is 9 to the x. So that first term is 9 to the x, and for similar reasons, the last term is 9 to the negative x. Now this middle term, 3 to the x times 3 to the negative x, the laws of exponents tell us that that is 3 to the x plus negative x. Well, x plus negative x is 0, and 3 to the 0 is 1. So those two terms just multiply to be 1, and so we just get 2 times 1, or 2. Well, now if we subtract 2 from both sides, what we get is 9 to the x plus 9 to the negative x equals b. And this is the exact equation that we're being asked about. So it turns out this statement by itself is sufficient. Now, I went through quite a bit there about squaring binomials and about the laws of exponents. If all that stuff is making your head spin, I highly recommend check out Magoosh.com. Magoosh.com is an online test prep agency with a few hundred videos preparing you with math, also a few hundred on the verbal side. We will teach you everything that you need to know for the GMAT about exponents, about binomials, about radicals, and all the rest of that. So do check out Magoosh.com. Statement number 1 is sufficient. Now statement number 2, a much more meager statement, tells us that x is greater than 0. Well, first of all, it's an inequality, not an equation, so that's not going to determine much of anything. But more to the point, well, it tells us a little bit about x. It gives us no information about b at all. And of course, we can't figure out what's going on in the equation without knowing the value of x and the value of b, or at least some relationship between them. So because we know nothing about b, statement number 2 is insufficient. 1 is sufficient, 2 is insufficient, answer choice A.